Hello students, hope you are all are in a very good health. We were on geography and in geography chapter number 3 are changing earth, right? So part 1 we have done. So today we will do the part 2 of chapter number 3. Part In chapter 3 part 2 we will learn these topics. Just look at the topics. First we will learn about the earthquakes. Second, the kinds of earthquake waves. Number 3, we will learn about how to measure the earthquakes. Major earthquakes in India, we will learn about. And after that, we will learn about the distribution of earthquakes, okay, in the whole world. The belts, right? As we have done in volcanoes. So, first, we will learn about the earthquakes. So, what are earthquakes, which are the sudden shaking of the earth that is caused by the internal forces of the earth is called the earthquake. Whenever any internal force is going on inside the earth, our earth shakes, right? So that sudden shaking is called the earthquake. It originates from the interior of the earth. Obvious, the movements are from internal part, so it happens in interior of the earth, and the point of origin of the earthquake is called focus. Okay, from where inside the earth, from where the earthquake is originating, that is called focus. The point on the surface of the earth, exactly above the focus, means inside the earth where the focus is there, where from where the earthquake is originating, exact at the same point at the surface of the earth, that point is called the epicenter. Okay, now remember this is called epicenter, or inside the earth it is called focus. So the earthquakes send shock waves all around and cause widespread destruction to life and property. Okay, so obvious we all are aware of, if the earthquake is of a very high Richter scale, so it causes a lot of destruction. So that, just look at the seismic waves. What are seismic waves, which are the vibrations due to earthquakes, volcanic eruption, magma movement, large landslides, etc. The vibration on the earth, upon the earth, on the surface of the earth, due to these reasons are called seismic waves. Okay, the vibrations of an earthquake spread out as concentric waves from the focus. As I told you that focus is the point inside the earth from where the earthquake is originating, right? So when the from the focus the earthquake originates, there are vibrations. Okay, the concentric waves that are coming out due to the vibration, they are the seismic wave. The intensity of an earthquake is maximum near its epicenter. Okay, at the epicenter the intensity of the earthquake is maximum. That's why it happens that at some places there is a lot of destruction due to the same earthquake, and at some point there is no destruction over there, right? So at the epicenters, the intensity of the earthquake is maximum. The surface of the earth can shake due to movements of the lithospheric plates, volcanic eruptions, and even bomb explosions. Okay, so earthquake shakes due to these such reasons also. Just look at the origin of earthquake with the help of a diagram. Here you can see, Vijay, this is the picture of the earth, inside the earth, and here you can see that in between, where this corner part is here. Here is labeled as focus. In between means these are the waves, and around the waves the labeling is of focus. Okay, the center point, that is called the focus, and from the focus the below part is called the fault line. Okay, or the subsurface. At the top, just look at it, at the top means just above the focus, at the same line, the parallel line, that is the epicenter at the surface of the earth. Okay, on the surface of the earth it is called epicenter. Under the earth it is called, from where the earthquake is originating, that is called a focus. And here you can see the red lines. If you can see the red lines, these red lines are the seismic waves. Okay, the waves that are producing the vibration around the earth. Okay, at the top, this is the fault line. Fault line means if it is breaking from inside, and the the green part, the dark green arrows that are given over here, they are used for the plate movements. Okay, plate movements means movement of the rocks. Okay, so this is the picture of your, this is the diagram or picture you can say of the origin of the earth. Next, we will learn about the kinds of earthquake waves. Okay, so earthquake waves, which are, there are major three kinds of earthquake waves. First is the primary waves, and they are also called the P waves. Number two is the secondary waves, and they are also called the S waves. And number three is your surface waves. Okay, primary waves. Now, what are primary waves? Primary waves, as the name suggests, which are, they are the first waves. Okay, so the primary waves are the fastest and the foremost waves. Okay, so they are very fast. Why? Because they are the straight waves. I will show you the diagram as well. So they are the first signal from an earthquake to arrive at any affected location on seismograph. So what is seismograph? Which is, seismograph is a machine, or you can say a graph to measure the earthquakes. Okay, so that also I will mention later on. So they are also called P waves and push waves. Okay, so they are, because of the primary waves name, they are also called the P waves and push waves. These waves generally travel at a speed of about 6 kilometer per second. Okay, this is their traveling speed. Small displacements are caused by these waves. What is displacement? Displacement means the change in the place of something. Okay, P waves may be transmitted through gases, liquids, or solids. So they can transmit due to all these three things: gases, liquids, and solids. Okay, get the diagram of the primary waves. So here is the diagram of the primary waves, where the waves go straight, but sometimes they compress and sometimes they expand. Okay, so here you can see in the diagram where the lines are very close to each other, that is the compression, and where they are expanding, okay, themselves, that is called the expansion. Okay, and this is the direction of wave propagation at that side. Okay, at your right hand side. So this is the diagram of primary. Now secondary wave. What are secondary waves, which are? Secondary waves are also called S waves. They arrive after the P waves. Okay. So they are also termed as S waves or shock waves. So the rate of P wave is higher than that of the S wave. Why? Because P wave goes straight and S wave little fluctuate. I will show you the diagram. A strong shaking action is produced by S wave. Okay, a very strong shaking action is produced by S waves. Why? Because they are shaky, means they are the up and down movements. They do not pass through liquids. Okay, they cannot pass through liquids. Now, secondary waves, look at the diagram. Here you can see, which are, that there is a fluctuation in the movement of these waves, in the secondary waves. Okay, the upper part of it is called crest, and the lower part of this secondary wave is called through. Okay, so this is the direction of wave propagation, right hand side. Okay, so this is just now surface wave. What are surface waves? The surface waves, as the name suggests, they travel over the surface of the earth. Okay, at the top of the earth. They are the last to arrive. Most of the damage is caused by these waves. Obvious, most of the damage will be caused by these waves. Why? Because they are arriving at the surface of the earth. Okay, and they are very powerful, and their effect is not observed at great depths. Okay, inside the earth, in very great depths, their effect is not there. Their effect is at the surface of the earth. Okay, the diagram of it. So surface waves are those waves which travel through the surface of the earth. And here you can see the direction, which are the wavy direction, but upon the earth. The black lines are the the level of the earth, and they are shaking above the earth. Okay, so these are called the surface waves. Now, how to measure earthquakes? Now, measurement, how we can measure the earthquake. The science that deals with earthquakes is called seismology. Okay, seismology. Now, remember this name: seismology, seismograph, seismologist, and these are all the words used for measurement of earthquakes. How? The science that deals with earthquake is called seismology. The earthquake scientists are called seismologists. Okay, and they are experts who study the pattern of the earthquakes. Okay, seismograph is the instrument which records the intensity of the earthquake waves. Okay, so seismology, seismologists, and seismograph. These three are the things for measuring earthquakes. Okay, seismology is the science, seismographists are the scientists, and seismograph is the machine or instrument for measuring earthquakes. Okay. Now, Richter scale. Richter scale is very important, bache. So, Richter scale is the scale through which we measure the earthquakes. Okay. Richter scale was designed by the American seismologist Charles Richter, and upon his name also only the devices upon. Okay, so the name of the device is on his name only. It was invented in 1935. Okay, this device Richter scale was invented in 1935. The Richter scale has the range of 0 to 9. Okay, from 0 to 9 it is having the scale, and the Richter scale clearly states that the force of the earthquake is 10 times greater than that of the previous one. Okay, so means the range is like that. If from 0 to 1 the earthquake is going, that means it is 10 times higher than the previous one. Got it? So earthquake is 10 times greater than that of the previous one if there is an increase in 1 point. So all the earthquakes that measure 6 and above are termed as very destructive. Okay, just look at it. This is the Richter scale. Here you can see that from 0 to 9. So from 0 not felt, at 0 to 2 it is not felt, means it is inside the earth only. From 3 to 4 it is minor, and at 5 level it is small, 6 moderate, and above 6 it is strong. As you can see the gap on the diagram, that it is very high, it is very strong at 7 point, and 8 point it is major, and at 9 point it is very great. Okay, great means it is at the highest level, and it causes a great destruction, a lot of destruction. Okay, and here Richter scale, each level indicates 10 times the amount of shaking and 33 times the amount of energy. Okay, each Richter scale from 1 to 9, 0 to 9. So here's the diagram of your this is your seismograph. So seismograph, here you can see which there is a base at the ground. Here this side are the horizontal earth movements. At the top it is frame that is transmitting earth's vibration on wire, and this is the frame. This is the rotating paper drum on which the paper is there. The pen for designing the waves over there. This is the heavy weight attached with the wire. Seismograph tracing on vibrations. Okay, so this is the seismograph, Pachi. On this particular paper, the all these waves and the measurement of waves has been done. Okay, so this is seismograph. Next is your major disasters in India due to different things, but especially with earthquakes. Okay, it is in your book also at different parts. Earthquake in Bhuj in January 2001, earthquake in Sletor in Maharashtra in 1993. These are very destructive. Okay, earthquake in Jammu and Kashmir in October 2005, in Uttarkashi in 1991, and Chamoli in 1999. So these are the major earthquakes happened over here in our India. Next is the distribution of earthquakes. Now, distribution of earthquakes. Earthquakes frequently occurs in different parts of the world. However, they occur more frequently in some specific areas. And there are three major belts of earthquakes. Belts we have done in volcanoes also now. So same in earthquakes also it happen. First is circum-Pacific belt, then mid-continental belt, and third is mid-Atlantic. Circum-Pacific belt. So circum-Pacific belt, it consists of East Asia, South America, and the coastal margins of the North America. 65% of the total earthquakes of the world occur in this belt. Okay, so the highest volcanoes are also higher over there, active volcanoes, and the earthquakes also. So it also called the Pacific Ring of Fire. We all are aware of due to the volcano. Now this is the diagram. Here the red triangles over here. These are the sign of these are the belts of the earthquakes. Okay, mid-continental belt. So this belt includes northern and eastern Africa, alpine mountains, Himalayas, and the Mediterranean Sea. Okay, so these are the places where this belt includes. 25% of the seismic events occur in this belt. Okay, in Pacific 65 and in mid-continental 25% seismic. Now, Mid-Atlantic Ridge Belt. This particular belt includes Mid-Atlantic Ridge, as the name suggests, and the adjoining islands. Moderate earthquakes are recorded over here, not very big earthquakes. So these are caused due to the moving of lithospheric plates in the opposite directions. If the lithospheric plates are moving towards the opposite direction, then the earthquakes happen over here. Okay, the diagram of the world. So recorded earthquake, the red points as you can see on the map of the world, and earthquake belts are covered with the orange color here you can see. Okay, these all are the earthquake belts and the major earthquakes that are recorded. These are pointed with the red color. Okay, so this was your chapter number 3, bacha. And now this is the end of the chapter. Thank you so much. Read the chapter, look at the video, watch the video carefully, and you can ask me the queries in your session. Okay, so take care of yourself. Goodbye.